Hello, this is Randy. Today we're going to learn the difference between the general concept of factoring monomials and the more specific concept of completely factoring monomials. Let's do this. So before we try to factor 12x cubed y squared, let's talk about what does it really mean to factor a monomial. It's pretty simple. To factor a monomial like this, we just need to separate the original expression into two or more expressions that, when multiplied, will still give us the original expression. So we're going to do 4 examples of correct factorizations of this monomial. So you could say something like 4 times 3 times x cubed times y squared. We know that this is a correct factorization of the original expression because 4 times 3 times x cubed times y squared is the original. Okay. We could also write something like 6 times 2 times x squared times y squared, and we still will have a correct factorization because all of these multiplied together will give us the original expression. Okay, let's do another factorization here. We'll say this time 4 times 3 times x times x times x times y squared. Okay, all of this multiplied together will still give us the original. 4 times 3 is 12. X times x times x is the same as saying x cubed, and y squared is y squared. Now let's do one more factorization here, and then we'll talk about the concept of completely factoring a monomial. So this time we're going to say 2 times 2 times 3 times x cubed times y squared. And once again, we still have a correct factorization because all of these numbers and variables multiplied together will give us the original expression. Okay. Now, what is a complete factorization? You'll notice that we have, many different versions of factoring, right? But when we completely factor an expression, that's more specific because in order to completely factor an expression, we need to do the following. First of all, we need to do a prime factorization of the part of the expression that has no variables, and then we need to expand each part of the expression that has variables to the point where all of the variables have an exponent of only 1. Okay, so let's do that with this example, and then we will have a good understanding of how to completely factor a monomial. So 12 can be factored into 6 times 2, 6 times 2, but this is not a prime factorization yet because 6 can be separated into 3 times 2. So 12 factored into a prime factorization is going to be, as most of us should know, 3 times 2 times 2. And now x cubed expanded to the point where all of the variables have the exponent of 1 is going to be x times x times x. So we have 3 times 2 times 2 times x times x times x. And lastly, y squared expanded to the point where there is only the exponent of 1 on each variable is y times y. So we have times y and times y. And now we can see that if we multiply all of this, once again, we're still going to get the original. Okay. So looking at this example, we can tell that the more complex that our original expression is, the more possibilities of factorizations there will be. However, when we are doing a complete factorization, there is only one possible right answer. And it is important to keep in mind that the order of these parts of the factorization could be different, and that would still be a complete factorization. But each part that we see right here, the 3, the 2, and the 2, x, y, and y, need to exist in the complete factorization in order for it to be correct, even if the order is different. And with that, we are finished with this video. We'll see you next time.